Hi everybody. In this video, we're going to look at modeling real-life situations using trigonometry. So we'll work through a couple of questions, and if you want to work along with me, you can download a copy of this PDF from my website. I'll leave a link below. So if we begin with example 1, we need to express 3 cos theta plus 4 sine theta in this form, where r and alpha are constants. So to expand this out, we need to use the compound angle formulae. So 3 cos theta plus 4 sine theta will be identical to r multiplied by the cos of theta minus alpha. And then using the compound formulae, this will be r cos of theta cos of alpha. We'll change this negative to a positive, and we'll have r sine theta sine alpha. And then you can see that this cos theta will match with this one. So r cos alpha must equal 3. This sine theta will match with this one. So the 4 must be the r sine alpha. Now to work out r, we can use the Pythagorean identity, where sine squared alpha plus cos squared alpha will equal 1. If we divide both sides by r, then the sine of alpha will be 4 over r, which we need to square. And if we divide both sides by r here, we'll get the cos of alpha is 3 over r. And together they'll make 1. So if we expand the brackets out and move the r squared to the right-hand side, then 4 squared plus 3 squared will equal r squared. So you can see that r will equal 5. And then to work out alpha, well, we know that tan of alpha is equal to sine alpha over cos alpha. Sine alpha will be 4 over r, and cos alpha will be 3 over r. We can simplify this fraction, so we get tan alpha is going to be 4 over 3. We'll take the arctan on both sides, and alpha is 53.1 degrees to 1 decimal place. So 3 cos theta plus 4 sine theta is identical to 5 times the cos theta minus 53.1. Now for part B, we're told that the temperature as a function of T of a hall is modelled using this equation, where T is the time in hours from midday between 0 to 24. We need to calculate the minimum temperature of a hall and then find the value of T when this minimum temperature occurs. So if you notice, the 3 cos of 15t plus the 4 sine of 15t, it's very similar to what we have here. We just need to replace theta with 15t. So we can rewrite this function of time. This will be the 10 plus 5 cos of theta, which is 15t, minus that 53.1. So this is a much simpler way of writing this function. Now to work out the minimum, well, if we sketch the cos graph, we know this ranges from positive 1 to negative 1. So the minimum will be when this is negative 1. And when it is negative 1, we'll multiply that by 5 and we'll get negative 5. So the minimum temperature will be the 10 minus a 5. So this will be 5 degrees. And the minimum temperature will occur at this point where it's negative 1. So this is 180 degrees. We can solve this equation and T works out as 15.54. We can work this time out in hours and minutes. We've got 15 hours from midday, so this will be 3 a.m. and 0.54 of an hour, so 0.54 of 60 minutes, which gives us just over 32 minutes. So the minimum temperature will be at 0332, and this will be at 5 degrees, okay? Let's try another question. So do you want to read through question 2 yourself? And then try questions A and question B. You can pause the video, and when you come back, we'll go through the solution. Okay, so welcome back if you had a go. We'll start by expanding this out. So we'll have 6 cos of x plus 2.5 sine x. This will be identical to r cos x cos alpha plus r sine x sine alpha. So the r cos alpha will equal 6, and the r sine alpha will equal 2.5. So we can work out alpha as the sine divided by cos. We'll take the arctan on both sides, and alpha works out to be approximately 0.395 radians. We know to use radians because we've been given 2 pi here. And r will be the square root of the 6 squared plus the 2.5 squared. And this works out to be 6.5. So 6 cos x plus 2.5 sine x is identical to 6.5 times the cos of x minus 0.395. And then for part B, we need to substitute all of this into this part of h. Now x will be 2 pi t over 52. So we'll write h will equal 12 plus 6.5 cos of 2 pi t over 52 minus the 0.395. To find the maximum and the minimum values of h, well again, we know that the cos will range from -1 to +1. So the maximum will be when this is +1, so we'll have 12 plus 6.5, and the minimum will be when this is -1, so we'll have 12 minus 6.5. And then for part C, find the values of t when h equals 16. So 16 will equal 12 plus the 6.5 cos of 2.5 t over 52 minus the 0.395. So we'll take away the 12 from both sides, and then we'll divide by 6.5. So we'll get 0.6154 will equal the cos of that angle. And then if we take the arc cos of both sides, we get 0.907 radians will be 2 pi t over 52 minus 0.395. I'll get rid of that 1. We can find the solution to this within the range. We'll draw a cast diagram. We know this is positive, so we're looking in the first quadrant and the fourth quadrant. So our solutions will be at 0.907 and 5.376. And when we solve each of these for this right-hand side, we get t to be 11 and 48 weeks. Well, thank you for watching. I hope you found that useful. If you did find that helpful, you can download the worksheet and view the online lesson from my website, mrmathematics.com. I'll leave a link below.